Okay girls, today's a really big day because we're going to be solving some quadratic equations. Remember, quadratic equations are ones that have an x squared in them. Have an x squared in them. So that's our trick, is finding that, and then we'll know how to use the methods we're going to use today. A really, maybe the most important theorem of all of maths is called the null factor theorem. And by null, of course, we mean zero. Okay? So in America, we even call it the zero product property. Okay, so it's got different names. So here's how it works. It says if I'm multiplying two things together, let's just use variables, a times b, and I get 0, what has to be true? Well, I hope in your head just now you said, or even out loud, one of these has to be 0. I can't multiply two non-zero numbers like 3 times 5 and get 0. So either A has to be 0, or B has to be 0, or both are 0. Super important. Both are 0. Sorry. All right, so let's use that property to do this. This is in factorized form. It's already been factorized, and it's equal to 0. And so this is what I'm saying here. I'm saying, all right, I have x times x minus 14. I have two things being multiplied together. You know there's a time sign between there. So since I'm multiplying two things together to get 0, either x is equal to 0, that one, or x minus 14 is equal to 0. Now I'm going to solve that for x, and I get two answers. You notice in here it says find the values, determine the values of x. Okay, this one's in factorized form. Where's the multiplication sign? The multiplication sign is right in between there. So I'm going to take this one, x plus 3, and set it equal to 0, and x plus 7, set it equal to 0. So what I do is I take each factor and set it equal to 0. Now the question lots of times from kids is, you know, how can x be two different things in the same problem? It's not. It's either -3 or it's -7. Okay? It can be either of those things, each one at a time. This has not been factorized, and I can't set x squared equal to 0 and -25 equal to 0. It doesn't say the null subtraction theorem. It says product or factor. I have to factorize. So you'll remember how to factorize the difference of two perfect squares, I hope. And some of you are going, oh, but that's going to be on your test, so you got to remember it. Now once it's in factorized form, I take each factor separately and set it equal to 0. Each factor separately, set it equal to 0. -5 or 5. I'm sorry if it glitched when I was there, but I set each factor equal to 0. How do you factorize that? Pause for a minute and try to factorize this. Hopefully when you came back, you had that. And so I'm going to take each factor, the multiplication sign is right there, and I'm going to do 2x equals 0, or x minus 6 equals 0. When I divide 0 by 2, I get 0, and then I add 6. Those are my two answers. Okay, not that bad. Now, there's one hard one on here. This is much harder than I'd have on a test, but sometimes the problem isn't set up right. There's no 0 in it. So I'm going to get a 0 in it. I'm going to make everything go to the left side. I'm going to make everything go to the left side so I can make it equal to 0. So I'm going to take this over by doing -2x squared, -2x squared. Well, 6x squared minus 2x squared is 4x squared. And when I take that 81 across the equals bar, it becomes -81. And now I have something equal to 0. Now, maybe you remember how to factorize this, maybe you don't. It is the difference of two perfect squares. It's 2x plus 9, 2x minus 9. All right, so when I set this one equal to 0, Wow, I get a creepy fraction. And same when I set this one equal to 0. Add 9. Divide by 2. Girls, this is extension. This is not the kind of problem that's going to be on a test, but I wanted to show some of you. Okay, here's your bookwork. It's 10A, number 9 and number 10. Do them all.